Okay, welcome to Unit 2 Computer Science. This is the IA, and well, hopefully you would have watched the previous series last year, maybe, with the walkthrough for the Computer Science IA. That exact IA that I did for Unit 1 in the link in the description, most likely, is going to give you the code and stuff. So we build in from the Unit 1 IA and moving up. So before I jump into the actual IA and doing the actual things that we need to do, I need to explain to you the concepts and the things that we're going to face and some of the issues that may pop up, and then we will kind of tackle the problem definition a little bit and see if we could get the problem definition out to show you how it changes, right? Sorry to interrupt the video, but this is future me talking to you while you're watching this, and if you are struggling with a certain part of your IA or you just need some way to check over your IA, we do personal one-on-one IA classes. So if you want your IA to get a check over, just to make sure you have all the requirements on the marks, makeITsimpleTT.com/register. Okay, cool, back to the video. So in Unit 2, they want you to do something that is along the lines of what the syllabus teaches you, because Unit 2, the syllabus in Module 2, I believe, it teaches you about software engineering. So your goal in Unit 2 is to do actual software engineering and take existing software and make it better. Now the thing is, you have existing software from Unit 1, so you could take that Unit 1 software and you can make that better because you have learned new things in Unit 2. Namely, you learn how to do like a better search, you learn how to do sorting, you may have learned a little bit about user interface design and such like that. So those are things that you apply inside Unit 2, and you can see that the syllabus is kind of guiding you that way. Now in the past, some teachers used to make you do a totally new code for Unit 2, which is possible, but I'm not too sure if that's exactly what they want you to do, because it clearly says you have to find something for which a software solution, right? So, okay, so look at Unit 2. Unit 2 says the candidates are expected to choose a problem for which a software solution exists and develop the software using software engineering techniques. So that means there should be a program already done, and what you're going to do is to make that program better by applying software engineering to it. So I believe, in my humble opinion, that your goal is to take your Unit 1 IA and make it better. If that is not the case, I would love if a teacher or somebody who marks IAs would correct me. But thing is, I've spoken to people who, I speak to teachers who mark IAs, and they say that they don't know the difference between a Unit 1 and a Unit 2 IA. Well, sorry, they don't know when a Unit 1 IA is used as a Unit 2 IA. So they're all marked independently. So there's no way to check to see if the person used previous code and put it into Unit 2. Some teachers may decide to take other people's programs and give it to a student and tell them to make that program better in Unit 2, where you might exchange code or some kind of thing like that. That's a possibility. So I can't tell you exactly how it's going to flesh out, but I can let you know that there must be a program already done and you are trying to make that program better or add a new aspect to it, or create some sort of new functionality from the current program that exists, right? Now, mark scheme. So the mark scheme of this project is, there's a lot of documentation in between here. You can get the syllabus, check it out on your own. Syllabuses are easy to get these days. Might put a link in the description, maybe not. So here's what they're looking for inside this this Unit 2 IA. They want you to give us specification as requirements, design specification, coding and testing, communication of information. So then the marks are broken down that way because specification of requirements means you have to actually analyze what the current system is using, how it's working, and what issues they're having. Draw some diagrams for it. A lot of it is like diagrams and writing. The Unit 2 IA is a lot more writing and a lot more explanations, and not as much code as before. The design specification, more diagrams again, more things about user interface, and then coding and testing, which was really big in Unit 1, is not as big in Unit 2 because you are basically modifying code or adding coding, not really coding from scratch anymore. And then communication of information, that is still there. So let's see what they're looking for. They are looking for a problem definition, so you must clearly define the problem. Whereas in Unit 1, they didn't ask you for a problem definition. they just ask you for functional requirements one time. But in the top part of Unit 1, they did say that they're looking for a problem definition. So I'll just kind of leave that there. But they want a problem definition here, and the problem definition is 5 marks, so therefore, we have to put some effort into that problem definition. Then they have techniques of analysis, where you have to actually analyze the current system and get some sort of understanding of what are the needs for the upgrades that they want to have to the system. Now, whether this is a real IA, like a real place, or whether it's a fabricated place, that is something you and a teacher are going to have to sit down and discuss, because there's a fight between choosing a real place and choosing a fabricated place. But if you choose a real place, they have to have a software system in place. And if they have to have a software system in place, that means you have to know somewhere that actually using a computerized system, which may not be always possible. But some of the examples of things that they say that they want you to do for this section aren't real places. So there's a process scheduler for an operating system. That is not a real place. You are not going to go and get like interviews from there. A vehicle parking system to allocate spaces in a parking lot. You're not going to get any information. You're not going to do any interviews, questionnaires, observations from like that. Nobody's going to find that. The only one that you might find is a student registration system to keep track of student information, course grades, and registration details. You might find that. But, I mean, I am not going into whether you should fabricate your research or not. You talk to your teacher, you sort that out. Then, one of the biggest set of marks will be data flow diagrams and entity relationship diagrams. So you have to draw 2 data flow diagrams. One is a context level, which is basically data flows and entities. And then you have to do a level 1 diagram, which will be data flows, data stores, processes, and entities. But as of the current system, because in the analysis of the system, you're trying to analyze how the system currently works. Then you have to do an ERD diagram of this current system. Now remember, all these diagrams are of the current system. I'll repeat that. All these diagrams are of the current system, not the system you plan to build. You are in the process of doing a specification of requirements. So what you are doing is you are doing analysis for the most part. Then functional requirements and non-functional requirements. That is going to now take you into the new system that you're going to build, where you're going to say, all right, the functional requirements for this system should be that they should be able to search efficiently. But right now they're using a linear search. So therefore you should be able to change that to a binary search. Or you might say that, well, the data isn't sorted, so therefore you should sort the data and display to them in sorted order. Something like that will, add some functional requirements and non-functional requirements. So we'll add those in. Then system structuring, which is 14 marks. This part here is crazy. There's like all of these here, we haven't written a piece of code yet. We literally just writing our understanding of software engineering. So system structuring is a diagram. So we draw that diagram, we create that diagram, user interface design, more diagrams, but you can't use screenshots, but I'll explain that when we get to that point. Report design is going to show you what the report's supposed to look like. Algorithm design is going to allow you to show that your algorithm is well laid out, and you have to explain why. And then choice of appropriate data structures. You're going to take the same thing that you did from Unit 1 and kind of bring it in, but you might add in more data structures. You might add in a new structure into the program because it's software engineering, so you might make it better. I haven't decided if I'm going to add in a new structure yet. I'll think about it, but based on the requirements, you may not have to add in a new structure. Based on the requirements, if you have a structure in place already and you have like robustness, there's nothing that says that you need to have 2 data structures inside of it. You may want to do it if you feel like it, if you feel ambitious. But read from a file, write to a file, produce some reports. One of the most important things you could see is clearly they must have reports. So, and user interface changes. So I just usually tell students, okay, we're taking the same IA, taking the same data structures and whatnot, but now we're going to create some new functions to get some more meaningful reports out of it. And then there's coding and testing, which is 15 marks. Notice the design specification is 14 marks and coding and testing is 15 marks. So it's almost the same thing for designing and then coding. But now, whereas coding was half the marks in the last IA, or about a third, or I don't know, something 2/3 of the mark in the last IA, in this one, coding and testing is not that much. So 5 marks really and truly for your coding to work properly. But you will see that there are some key things that they state here. Documentation, error trapping, correct output, usability and reporting. These are things that we're trying to aim for when you make your software better. So software engineering is going to boost the software in all aspects, which is what we're going to try to do, right? Then you have code response to design. So the same design that you did in design specifications up here with the system structure and user interface design. Code response to design in all specifications. So basically, the menu layout and the user interface design, they're looking for that matching back up with your print screens. And then you have your test plans with an exhaustive data set, acceptable data set, minimal data set. Now, when you did the test plans in Unit 1, you had to do data sets, but you only got 3 marks with it, but now your data sets are 5 marks. The reason why your data set has to get more robust is because you're adding more complex functions to the code. So you need to use better data sets to test those functions. For example, you might try to do a binary search, which we will, ambitiously try to attempt. As far as I know, a linear search should work, because I've spoken to teachers who mark the Unit 2I, and they'd be like, well, yeah, we just check for a linear search. You don't have to put in a binary search unless you said that you're going to put in a binary search. But we will try to make sure that we use a data set that is able to test for everything, because they're not telling you like they did in Unit 1, test for erroneous, test for missing, test for extreme high, extreme low, and correct data. You just have to understand that, well, that's standard testing, right? So we get to test that, the test plan should be there. And then they have a full 6 marks for communication of information, because this IA is very word heavy. This is not code heavy, even though you still have to put your code in and you still have to put the algorithm in. But they're assuming that you know how to do that already. So that's the mark scheme for it, and there's no two ways about it. You have a lot of typing to do, and you have a lot of thinking through to do, and you have a lot of planning to do, because software engineering, half of it is more planning than actually coding. The coding part is almost like second nature now. So let's take a jump into the documents. Just like how we prepared the documents before, what you want to do is you want to set up your cover page, and you want to set up all of your wordings, just like how the syllabus sets it up, and all the things that they are looking for marks for, you want to make sure you put that as subheadings. So you see I have specifications of requirements, design specification, coding and testing, just like how they have specification of requirements, design specification, coding and testing, exactly what they have as their main points. You want to do those main points. The only one you're not putting in is communication and presentation, because that's the whole thing. So every single thing that they want to get marks for, you lay it out, because an examiner is going to look at this. When the examiner looks at this, they want to be able to say, all right, cool, 1 mark, 2 mark, 3 mark, 4 marks, 5 marks, depending on how you go, right? Definition, technical analysis, data flow diagrams, context level 1, that's subheadings under that. ERD diagram, functional and non-functional requirements. From there, design specifications, diagram, pictures, whatnot, algorithm design, show the algorithm inside there, appropriate data structures, clearly give everything, so there is no question about it. Then coding and testing, you paste your code, show that the code achieves functionality, you show that the code matches the design that you intentionally wanted it to have, you train a test plan, and then you have an appendix that will show whatever stuff, right? So let's go in this video and try to do the problem definition. Now the problem definition inside this one is a full 5 marks. There was no marks for problem definition in Unit 1, but we did put 1 in. So what we're going to do is we are going to take the problem definition from Unit 1 and we're going to beef it up, because they want a complete, accurate description of the problem. Now, in this case, in Unit 1, the problem was there was no software solution. In Unit 2, the problem is the software solution is inadequate. So somewhere along the line, we have to make sure that we clearly show that the software solution is inadequate. And the only way that it could be inadequate would be first to point out that it does things poorly or inefficiently or something like that. So basically, you're going to jack the problem definition from the previous IA, Unit 1. Take that, and we're going to drop it straight inside here because we can. We want to put this as Times New Roman and double spaced in one time, because what will happen is they have a lot of marks for documentation in here, so we want to try to not get them vexed and say that, oh, y'all didn't use APA formatting, and you really don't want to have that problem in your life, right? So put it as Times New Roman or whatnot. In Unit 1, I didn't do that because they didn't ask for it like that. So Unit 1, I left it as Arial, but for Unit 2, because there are 6 marks for formatting, double spacing might be something that they're looking for in the formatting. But we can't say 100, we can't be 100% sure about it, right? So here's our goal. Our goal is, in the problem definition, we want to give details about the actual problems staff or clients face and propose steps to correct them. The problem should be emphasized. So we want to talk about the company, we want to talk about the software system that they currently have, what the system intends to do, the problems they face, the negative effects of the business, and the proposed steps to correct it. So we're looking at 3 to 4 paragraphs because it's at 5 marks. 5 marks are we looking for. So for those 5 marks, we should be able to show that there is a software system and we need to fix it. So previously I had the Port of Spain General Hospital currently collects patient data in a notebook when they come in. Alright, so we're changing that. Currently collects patient data on a software system custom built for their hospital. Why can't I spell there properly? Their hospital, right? Patients, so the patients don't have to write anything anymore. The patients have the administration has to put the information, right? The administrative staff has to type the information in for patients after they fill out their forms. After they fill out a form. Okay, cool. That sounds good. The system collects the data and produces reports that are then printed and given to doctors. They also have the ability to add and update patient information as their time in the hospital, extends or comes to an end. Patients are classed under 3 categories. 1 is stable, 2 is warded, and 3 would be critical. Right, good. So based on what I remember from the last IA, that's what we have as the system that we built for it, and when it works and it was tested. However, there's some deficiencies in the system. So what we want to do is we want to hit the deficiencies in the system that we purposefully left there in Unit 1 because we didn't want to solve every single thing. If you watched all the Unit 1 videos, I kept saying over and over, we ain't trying to make the program perfect. We're trying to make the program solve a problem because perfection or engineering of it comes in Unit 2. And if you did too much in Unit 1, then in Unit 2 you really don't have anything to software engineer. So we kind of left some holes deliberately, right? So one of the holes that we left was that we had the ability to add and update a record, but we don't have the ability to remove a record. So we want to put in the current system can add and update records. However, they do not have the ability to remove a patient when they are discharged or deceased. Discharged or deceased. This has caused frustration because some patient names still come up in the searches and it confuses the staff. Alright, so we basically tell them that the fact that we can't delete a record, we have a problem. And because we have a problem, they have an issues and stuff here, right? We also want to say that additionally, there have been complaints that the system does not search fast enough because there are now too many patients to search for. This frustrates doctors. Right. They also can't get reports about all the other patients, only the critical, which should not be. Alright, cool. So we kind of pointed out, okay, we understand that the system is in place, we understand that it's currently working, but there are some deficiencies. So the hospital would like to, they don't just want a computerized solution, the hospital would like to upgrade their system to handle more feature, upgrade the system to address the missing feature set. If they get these upgrades to the system, they can better serve the patients and population. In order to do this, a proper analysis of the system has to be done, and a set of functions can be added. Added to the software. Yeah, right. I wish I could say more. I probably could say some more. You could massage it a little bit if you want, add in a few critical things, but once you go through this checklist and be like, okay, we said the institution, we spoke about the software system that they have, we talk about what the system intends to do, the problems that they face, the negative effects on the business, and the proposed steps to correct it. Yep, once we have that, we are ready. So 3 to 4 paragraphs under the guidance of your teacher. Depending on the problem that you have, you'll be able to say a lot more depending on the problem that you're dealing with. In this case, the problem is a hospital that we're trying to create reports for. So I think that problem definition is solid. So what we want to do is say to ourselves, did we get the 5 marks? Here's the problem, right? They don't really tell you how to get the 5 marks. You really just need to have an experienced teacher to be able to know how to do this, because I can tell you for a fact, like when I started teaching and I see complete accurate description of the problem, I had no idea what they wanted. What is a complete and accurate description of the problem in a computer science terms? Because in IT terms, a problem definition is a little different. In computer science terms, a problem definition is a lot more technical. But the kind of technicalities they want, nobody ever knows. And we go to workshops and teachers will gather, teachers will ask questions to CXC, CXC will answer, they'll tell you, we'll check that out for you and whatnot. And then you had to just basically wing it and say, okay, well, here's what to do, child, do this. So that's why I'm showing you all, these are the points that you're trying to cover. If you covered all those points in your 3 to 4 paragraphs, good. Take that and run with it, and your problem definition should be okay. Oh my goodness, I forget I was supposed to have the hoodie on, so I look like a hacker. Actually, I'll only put the hoodie on when I have to actually do the code. Yeah, we'll only do it like that. Right now, I'm an office worker in a hoodie. So that's the problem definition. I hope that helps. Check this out. Hopefully this PDF should be in the app by the time this video is out. So you might be able to just go in the app and search for this PDF and you'll be able to follow along with it. But the videos will be there, the recommended material will be right underneath, and we'll just kind of roll with it as we go along. So this video 1 for Unit 2, go download the app, makeITsimpleTT.com/learn it. Learn it is the app, download, you'll see all sorts of resources there, and past paper questions, answers, you might see some notes, all sorts of things inside there. So check that out. I'll see you in the next video where we will go to inside the techniques of analysis. We'll spend some time going through the techniques of analysis because there's so many different ways to analyze your fabricated IA, for those of you that fabricated.